whether you have weight given. Another one is if the weight is not given, then how do we want to combine it using the matrix in order that we will find the minimum spanning tree. Okay, so for the spanning tree here, the second algorithm that we are going to look at today is Kruska algorithm. So this only apply to the graph with the weight given. Okay, so these are the steps that we are going to do to find the minimum spanning tree. Again, we will choose the minimum weight first. But in this algorithm here, instead of we do the table one by one, right? What are we going to do is we'll put every weight given in the table first, and we put it in ascending order. The weight in ascending order. Okay. So like this one, for example, if this is the graph given, they want you to find the minimum spanning tree by using the Kruska algorithm. So what you need to do is you need to find using the table like this first. Every edges that you have, put it in the table. Start with the minimum and then one by one go up to the larger one. Okay, so you must do it in ascending order because this is for Kruska algorithm. The algorithm is we put the weight in ascending order. Okay, order. So if you look at the graph here, the minimum weight is BD. So the BD, we will put it as the first one. And then followed by 2, 4 here, you have one is DF, another one is AE, right? So after that, it will follow by DF and AE. So you see the table here. This one, we have 2, one is AE, one is DF. Now, these two, which one you do first, it doesn't matter, because their weight are the same, right? But later on, you need to see which one you want to choose, or either both of them can be chosen or one only. Okay. Then after that, the weight is 5, so you go to this BF 5. After that, you have CE, and you have 3, 7, which is AC, AF, and BE. So you have this one, AC, AF, and BE, all with the weight 7. And the last one is weight 8, which is BC, right? So every weight, you put it in the table like this. After that, we need to determine which one we want to remain in the graph given, or which one we need to delete. So if let's say you put delete, you put a question mark, meaning that if you say yes here, means you will delete the BD. If you say no here, means that you won't delete the BD. Okay? So for this weight 3, of course, this is a minimum. Of course, we will not delete the BD, right? So you can put as the N to represent no, and the Y will represent the yes. Then after we choose the BD, meaning that in the spanning tree we have, we will have one path here already, which is B to D. Then the second one, if you put AE first, then you can decide AE you want to include in your graph or not. So AE is here. Okay, we can choose this also. After the BD, we can choose AE. And after the AE, we can choose the DF also. Both the 4 also can be included in our spanning tree, because even though we choose both of them, we will not have any cycle inside the graph, right? Correct, right? So we need to include both of these 4. Okay? So this also will not be deleted. Then you go to the BF5. So the edges that we have included, AE and DF. This one, AE and DF, and also BD, right? Now, when you come to this BF here, if you include BF as well, you will notice that BD, DF, and BF, this one, you already included 2 just now, right? BD and DF. Can you still include BF? Cannot, isn't it? If you include BF, what will happen? What happened to the graph? It will be a cycle, right? So it will form a cycle here. That means we cannot choose this anymore. Then we need to delete the BF. So in this case, we will say yes. Okay, delete it. Then come to CE6. CE is here. CE, just now you only include AE, right? So that means the CE we can include it because no cycle yet. So this one no, not delete. You want to include it. AC7 can include or not? If you already include CE and AE, can you include AC? Cannot, right? Okay, because AC will form a cycle also. So this one you need to delete. How about AF? AF. We already have BD, we already have DF, AE, CE. Can we include AF? Yes, it won't form any cycle. Okay, so here you have 1, 2, 3, 4, 5. Okay, so not delete AF. How about BE? BE. Delete. Okay, so you see CE, AE, you already have AF, you already have FD, BD. If you include this again, it will form a cycle already, right? So BE need to delete. And the last one, BC, delete or not? Also delete, right? Okay, BC here. So if you choose a BC, then you will have BC, then you have CE, AE, and then you have AF. So this one will form a cycle inside. Okay, so you can try to draw, you will see a cycle there. So this one, you will delete also. Now we only have 1, 2, 3, 4, 5 edges that is not deleted. So they ask you to find the minimum spanning tree. Okay, find the minimum spanning tree. So we just draw again, whatever edges that we have chosen just now, draw out. Okay, so here we have AE, this one, then CE, this is AF, AF is 7, AE you have 4. And then the F, right? And this is BD 3. Whenever the question asks you to find the minimum spanning tree, after you draw the table, just now that one, then you need to draw this final spanning tree. Okay, after you have removed some of the edges, draw out what is the spanning tree you have. And if let's say the question also asks you to find the minimum total weight, then you just total up and get what is the total weight. Here the minimum total weight will be 24, right? Total up all. Okay? Understand? Cross-cut algorithm? Easy, right? Okay. So this is the spanning tree with the edges list out here. So if you already draw, no need to list lah. No more example already, huh? Now I give you a graph like this, for example, Okay, then I will label the weight. So this one is 2. This is 1. This one. Okay. If the graph is like this, this is E. Then, by using the cross-cut algorithm, try to find what is the minimum spanning tree. Construct the table like this,
7:40，我7:40起来，因为你在垦丁，我去垦丁公园，因为讲要吃早餐，起不来，日系，日系，真的喜欢，哼。 就是不要变成少的少个画历史有几个边，然后它的位就是
Finish?
要不要理什么？你理掉这个是
How many edges you
这样
get?
才不会变裁缝，所以你在里面是放一个，所以理掉就这样不要
8 edges. So the table for this one, if you follow this in ascending order, right? So you will have the first one is BF for the weight one. This is the weight one. Okay, so you can label this as the edges. This is the weight. And this one is whether you delete or not. Okay, then the second one is the weight 2. So you have AF and BC, weight 2, FH,
细小的位就是
also weight 2, 3, weight 2. Then for the weight 3, you have EG, weight 3. Any more? AB, also weight 3. Then weight 4. Yes. EF, we have weight 4. FG. And this one also weight 4. 2 only, right? And weight 5. FI. Weight 5. 1 only. Weight 6. CE. Weight 7. DG, right? Weight 7. And the last one is CD. Weight 9. Yeah. Okay. Which one we will not delete? HI. Oh, 2 1, BF and HI. So here. Okay. Altogether 13, correct?
Yes.
Okay, so the BF, will we delete this or not? BF?
Yes.
No, HI? No also. AF? No. BC? Okay, so you need to know now you already have a BF here. You already have HI here. Then you have the AF too. And then you come to BC here too. Not related, right? So we will not delete this. FH. FH2. Just now we only choose the HI, right? So now we still can have FH. No cycle also. EG. EG. Is there any cycle for EG? No also. So we won't delete also. AB. Yes, because we already have BF and AF, right? So AB will form a cycle here. So you need to delete the AB. How about EF? EF? Not delete or delete. Just now you have EG right here. And then do you have FG? Not yet, right? Not yet. It's because my FG are right at the back. So I can choose EF first. So this one non delete, then this one should be delete. Yes. If you write your FG first, then you will choose your FG first, right? So if you put FG in front of EF in your table, you can choose FG, then you need to delete EF lah. that Fi? Can we choose Fi? No, because we already have Hi and Fh, right? So Fh, Hi, if you still include Fi, it is already a cycle. Ce, can we delete Ce? Yes, because we already have, yes, we have Bc, Bf, Fe, right? So we need to delete the Ce. Okay, Ce need to delete, and then this one, Dg, need to delete or not? No, just now you choose this one, Ef, and then you choose Ef4, you choose Eg3. Okay, so these two you already chosen, and now we will choose Dg, not delete. And the last one, Cd, delete. Okay, so we get the 8 edges, which is not delete. And if you draw the spanning tree, right, you will see that Bf so this one is Bf, Fh, Fh, Hi, 1, and then we also have Af, which is the weight 2, followed by, this one already have Bc, 2, and then Eg, 3, Eg is 3, and then this one is Ef or Fg is up to you. This is Ef for mine. This one is 4, and then we have Dg, which is 7. So this is the minimum spanning tree we get, and altogether you have 8 edges. Maybe you can get different spanning tree with the same minimum total weight. Okay, not necessarily your spanning tree is the same like mine. If let's say you choose the Fg just now, then you don't have the Ef, so your line will be here, Fg. Okay. So what is the minimum total weight? What is the minimum total weight? 22. Okay, you should get the same answer also. Even your diagram here is different. If you still get 22, then correct. Okay, because that is of the alternative edges. And for this one, if let's say every time you have the number of vertices, let's say your vertices is 10, okay, then the edges that you will find until the minimum spanning tree should be 10 minus 1, which is 9. So for example, in this case, you have A to I, right, which is 9 vertices, correct? A to I, you have 9 vertices. And you see, after you find all the edges here, you only left 8 edges. So meaning that to find a minimum spanning tree, the number of edges should be the number of vertices minus 1. Okay? So if let's say you put your algorithm here in ascending order, right? if you already get the number of edges which is required, meaning that at the end here you will know that all the edges at the end should be deleted already, provided you find it correctly lah in front. Okay, so that is one of the advantage for this algorithm if you put it in ascending order, and we need to follow it like this also. Okay, so you see here you already have 1, 2, 3, 4, 5, 6, 7, 8, right? So meaning that the last one here it should be deleted already. Understand? Okay, any question? This is the last part of chapter 1. So the chapter for 3, right? You will learn the search, the 3 types of search: pre-order, in-order, and post-order, right? And then you know how to draw the binary tree, you know how to write the Fourier parentheses, and so on. Then besides that, you also learn the binary search tree, how to insert the label one by one, binary search tree. And after that, to get the spanning tree using the depth first search and breadth first search, you also know the method already, right? And followed by the algorithm to find the minimum spanning tree, which you have 2: Prim's algorithm, whether with weight or no weight, and for Kruskal algorithm, we only have the graph with weight. So that are the contents that you need to know for chapter 1. So far still okay? Okay, so if no problem, we go to chapter 2. Then you can try the tutorial question in the tutorial 2. Now, for the chapter 2 here, we will look at what is the languages. And before we go to the symbol using, we will go through some explanation by using the example. Some will use the English words, English sentences, and so on. Okay, so we want to compare by using the English words and the sentences, compare with what you will use in the string later on. Okay, so here you have to understand first what is the meaning of strings and sequences. I believe you have learned this in your previous discrete maths, right? What is the difference between strings and sequences? Still remember? What is string? Remember or not? String, you write all the elements without the comma, without the bracket, right? That is string. Sequences, we will write all the elements, separate them with a comma in between. How many times it happens, we will write out all the repeat number of times. If 0 happens for 2 times, you need to write 0 for 2. 0, 0, right? That is sequence. Okay. For string also, if it happens for 2 times, you will write 0, 0, 1, 1, and so on. Okay, that is a string. So, for example, now let's say we have set A with elements 0 and 1. So, if you want to write the element for in terms of string, so we can write it as here 0, 0, 1. This is the example of a string. We just combine the element from set A. You can have 1, 0, 1, 0, 1, 1, 1, 0, 0, and so on. All these are the examples of a string. Okay. A asterisk will represent the set of a string. And then if let's say we have the words inside the set A, he runs slowly. So we can form a string also by using the words here instead of the element one by one like this. So we will consider this as one element. You can combine it in a string, meaning that to form a sentence, you can say he runs slowly. So this will form a string for the set A. Okay, and of course you can have repeated elements. He. You can say double he slowly. Also slowly 2 times, and then runs. This is also one of the example of the string. Okay, any others string you can form from here?
Slowly run.
Give me any example.
Cynthia runs slowly.
Class, what are the examples you can have for the string here? Anything you can tell me. RSF2, why so quiet? RSW2, why so quiet? He. Or he only. He only. No need. If you don't use some of the animals, doesn't matter also. Okay? So you can have like this, and then runs. He also can. Okay, anything as long as it comes from these 3 words. Okay, next one. Now, if we want to know the language, we must have these 3 basic components to get a correct sentence. First is we need to know what are the words that we will use to form the final sentence. S normally is in the set S. And then the second one is you need to know the syntax of the language. Like you learn English, you need to know what is the correct sentence, right? When do you need to put the noun, when do you need to put the verb, and so on. So this is the syntax of the language. And the third one is the semantics of the language, means that what is the meaning? Is there any meaning or not if we form a sentence using the words given? Okay, like just now if you say he runs slowly, there is a meaning here, no problem, right? But if you say runs he slowly, do you think this have a correct semantic or not? And also the syntax? Not correct, isn't it? Even though you can form a string, but this is not the correct sentence. So they have a problem here with the syntax and the semantics also. So to have a correct language, these 3 components must be constructed properly. Okay? So for example, if the sequence of the words, if let's say in the English word that we use, follow the example just now. You say runs he slowly. This is one of the example, which is not a properly constructed sentence. We know that in the sentence we cannot have this word followed by the noun, right? This is verb runs. He is a noun, so we cannot get a verb come before a noun. Right? So that is not a properly constructed sentence. And what else? The example we can have properly constructed sentence but no meaning. Any example of the sentence like this one? The grammar is correct but no meaning. What is the example we can have? The chair, what happened to the chair? To get a correct sentence, slowly. Can we say like this? Is the grammar correct?
Huh?
Syntax correct or not? Huh? Is the syntax correct? The chair sings slowly. Correct, right? The chair is a noun followed by the verb and the adverb. Right? So the chair sings slowly. But this one, the semantic here, there is not meaning, no meaning lah, like this one. Because can the chair sing or not? Cannot, right? So even though the sentence is properly constructed with the correct grammar, but they have a problem with the meaning here, semantic problem. Okay? So this is what we say, even though they have a properly constructed sentence, but the meaning or semantic have problem. That means we also cannot form the correct sentence like this. Okay, so you can have other example also lah. You can put the table, laugh loudly. And so on. Okay? So these are the example of semantic problem sentence. Okay, example 4. Look at this. If let's say you have the arithmetic and the elements of the integer inside the set given from 0 to 9 with the operator plus, minus, multiply, divide at the bracket here. So we want to see whether the following here is a syntactically correct sentence or not, and whether they have meaning or not. Okay, look at the first one here. The bracket 3 plus 4 multiply 0 minus 4. Is this a properly constructed sentence or not? What is the answer if you need to find this? Negative 4. So this bracket here will tell you which part you can do first, and the syntax is correct or not is referred to your bracket and also the operator given. Okay. Then how about the second one? Why? Because? Because of what? Plus and multiply together, right? So if you do, you can only have one operator in between the two numbers, correct or not? So here you already have two operators together. Okay, so this is not a properly constructed sentence. How about the third one?
Properly constructed sentence with no meaning.
Why no meaning here?
The answer is math error.
Yes. 3 divide 2 minus 2. 2 minus 2, if you do first, you get 0, right? Okay, so you cannot get 3 divided by 0. Huh? So even though it is a properly constructed sentence, which we know that we can do the 2 minus 2 first, then only 3 divides, but it has no meaning. So these are the 3 examples for the 3 components just now. Then when we come to the fresh structure grammar, here this one you have the three components as I said just now, meaning that in the correct structure grammar we need to have all these. First is the set S again. What are the words we use to form the sentence? The V here will be the set of words including the word we use to form a sentence and some of the words that cannot use to form a sentence. What are the examples in the set V here? For example, I say the word just now, if you use a table, right, to form a sentence, and then the chair, and then shout loudly, and let's say I add in a verb, I add in a noun. So in this case, the word that we will use to form the sentence is table, chair, shout loudly, but the word that we don't use is verb and noun. You won't write this in your sentence, isn't it? But you know that there is a verb and there is a noun in your sentence, right? So these two are the words inside the set V, but it will not use to form a final sentence. Understand? So set S will only consist of table, chair, shout loudly. All the words to use to form the sentence. That is set S. V will include some of the words like this, where we cannot use it in the final sentence. Understand? That is the difference for set S and set V. Yeah? And then the production relation means a substitution. Let's say I start with the word sentence. Now I want to form a sentence. So I need to replace the sentence with something in order that I get the final sentence. So I need to replace the sentence with the, let's say I need to have a noun, I need to have a verb, adverb, and so on. So in this case, later on, I can replace this noun with another word here. He, for example. I can replace the verb here with runs and the adverb with slowly. Okay? So this arrow means the substitution. The word noun, verb, and adverb substitute with this sentence. Okay? So we call this as the production relation. And the starting point of the substitution or this production relation, we will always use, instead of you use the word sentence like this, if in the simple form, we can put it as V0. This one. Okay? The starting point. We can put it as V0. Just like the root of the tree. What is the first point of the tree? You start with the root, right? So the root we also put V0. Right? So this one also the same. It is the starting point. So here you have the example. For the adverb phrase, you have too fast. This one means that you describe the verb. Adverb is the word that we use to describe the verb. So too fast is adverb. Very happy, adjective. And then the massive dinosaur is noun phrase. This one, dinosaur, is noun. At dinner, preposition. And watch movie is a verb at phrase. Watch, watch is verb. So these are the example that the words we use in the final sentence and the phrase that we don't use in the final sentence. Okay? So if you combine all these, it will be inside set V. The set S will only have fast, happy, dinosaur, and watch. All this in the set S. Okay, this is the example to form a sentence from these four components here. The four components, as I told you just now, you have the set B, set S, the V0, and the production relation. Okay, so the words in the set S, you have all these. the V here will be the set S combined with all these words where we don't use this in our final sentence, but from the steps of the substitution, we need to show it one by one. Okay, so the starting point, we will have the sentence. We use the example of English sentence first, then later on only we go to the symbol. So the first one, we start with the sentence, then we will replace the sentence with the noun and predicate, because every sentence we have must have two main components. If you still remember what you learned in your English, you must have two main components, right? One is a noun, one is predicate. So the noun here, you can replace it with he or she. In the set given here, you have two nouns given, he, she. And the predicate, later on, we need to split down to another two components, which is the verb and adverb. So from the words given in the set S here, the verb, we can have runs, we have runs and drives, two, right? So you can replace the verb with these two words. And the adverb, which is to describe the word verbs, drive and runs, you can have these three here, the adverb. So these three adverbs, you can have carefully, slowly, frequently to replace with the adverb. Then now the question is, they want you to show how do you get the sentence he drives carefully from the starting word sentence. So we just replace one by one. Follow this step. Okay? Noun and predicate is you have these two components for a sentence, and then you replace the noun with he because you want to get he drives carefully, right? So the noun you will replace with he, the verb will replace with drives, and the adverb will replace with carefully. That is how you get the sentence he drives carefully, by substituting all these words one by one, step by step. Okay? And of course, we can show this in a tree diagram also. If you draw it in the tree diagram, the starting point will be the sentence, which is the root of the tree. Okay, then you follow this substitution here, noun and predicate. So noun at the left, predicate at the right. Now we can replace with he if we follow this sentence, and the predicate will replace with, what are we going to replace with it? Yes, we will replace with verb and adverb. And verb replace with this word here, right? Adverb replace with carefully. Okay, so this one we call it as the derivation tree for the sentence he drives carefully. Okay, you need a break now. So you take a 1 minute break, then